Hello, this is Unit 4.5, Solving a Linear System by Graphing. Okay, so far what we've done is we've looked at all the different representations of linear relationships. So we've looked at equations of linear relationships. We've looked at graphs of linear relationships. We've looked at table of values of them. And we've also looked at word problems, and we've figured out how to go between all of them. So arrows going in all directions. We should be able to go from any representation to any other representation. And we do this so that we can solve problems. And so that's what we're going to look at today, is solving what's called a linear system. And what a linear system is, it's a set of two or more linear equations, and we need to look at the two of them at the same time. And to solve a linear system, so solving a linear system means find that value or that point. And this is by graphing, to find that point where that's on both of the lines. And so let's just take a look at an example here. So here we've got a graph, and they both are representing, let's see, what do we have here? We've got Rex and Roxanne's bank accounts here. So this line here represents Rex's bank account, and then the other line represents Roxanne's bank account. So it looks like Roxanne started out with no money in her bank account, and she has been putting money in her bank account, and it's been going up at a steady rate. Rex, on the other hand, he started out with $3,600 in his bank account, and at a steady rate, Rex has been taking money out of his account. Okay, so let's take a look at some of these questions here. So it says, analyze the following graphical data. Who starts off with more money in the bank? Well, Rex started off with $3,600, so that's Rex. Whose relation is direct variation? Now, we haven't talked about direct variation or partial variation, so I'm just going to do it quickly right now. Direct variation means that the graph goes through 0, 0. Okay, so this is what we call direct variation. And that's what happens is that, so if we take a look at the graph, after 6 months, Roxanne has $600, and after 12 months she's got $1,200, and after 18 months she's got $1,800. And how much money she has in her account is always the same multiple as the number of months. So for her equation, because she starts at 0, her equation, it looks like, if I do a little rise over run here, so the rise here is 600 and the run is 6, so the croc is 600 over 6, which is $100 per month. So she starts off with nothing, so the amount in her account is $100 times the number of months that have gone by, and I'll use N for number of months. So this is what we call direct variation, because how much is in her account is always just the same multiple. However, with Rex, there is a rate of change, so let's see what he's doing. Pick any 2 points on the graph. So from 3,600 down to 2,800, that is a drop by 800. And then the run is from 0 over to 8, so that's a run of 8. So the croc is minus 800 over 8, which is minus $100 per month. So he's losing money. So Rex's equation, the amount of money in his account, he starts out with $3,600 and he's losing $100 every month. So he's what we call partial variation. And partial means, yes, there is a multiplication factor going on. So there is some multiplying going on right in this part of the equation. Just like with Roxanne, she has some multiplication going on in her equation. But Rex has that added piece, I'll use a different color, has the added piece of a starting value that isn't 0. Roxanne's starting value, right here at the beginning of the graph, her starting value is not at 0. So that's called direct variation. And with Rex, he's called partial variation. Variation because there is multiplication going on, but it is partially all multiplication. There's just that little bit of addition going on, addition or subtraction. Now, partial variation and direct variation, they don't have to go up or go down like the lines don't for direct variation. The line doesn't have to rise. A line can fall with direct variation. It would just fall down into the negatives. And similarly with partial variation doesn't have to fall. We could have a partial variation graph that, say, starts here at 1200 and then it also rises. So something like that maybe. As long as it's not starting at 0, it's definitely partial variation. Okay, so I'm going to erase some of this stuff here. Definitely erase that anyway. Okay, so whose relation is direct variation? Well, in this case, Roxanne's relation is direct variation. What is the point of intersection? So where do the two lines cross? So where they intersect, that's right here, and that's at 18 months and at, looks like $1,800. So it's 18 and 1,800. Remember, the horizontal number always comes first, and then the vertical number in an ordered pair. What does the point of intersection mean for this linear system? What it means is that after 18 months, they both have the same amount of money in their accounts. So at 18 months, they both have $1,800. Okay, and what is the equation of Rex's line? Well, I've already done the equation of Rex's. His amount, he started out with $3,600, and we're taking $100 off of that every month. And then with Roxanne, she's starting with 0, so we don't have to write that 0 in there, and she's just adding $100 a month. Now, the fact that it's $100 for both of them is just by coincidence for this particular problem. That doesn't always have to happen. Okay, so that is a linear system. It's two straight lines on the same graph, and the purpose of the system is to figure out where do those two lines meet. And that's it. And we're doing these graphically. Okay, so let's take a look at the next example. For this example, all we have is a table of values, and so we could do the equations, but right now I'm just going to do the table of values. So for the first one, I'm going to graph these points. So 0 and 200 is right there, and then 8 and 320 is about right there maybe. 16 and 440 is maybe about right there. 24 and 560 is maybe about right there. 32 and 680 is maybe about right there. And then 40 and 800 is right there. So that is a straight line. Okay. And now we'll do the other one in a different color. Let's use blue. So 0 and 0. So this one would be considered direct variation because it starts at 0. But the first one, the job offer number 1, actually I'll write that down there. Job offer number 1, that's what we would call partial variation because it doesn't start at 0. It starts at $200. So basically, job offer 1 says, hey, we'll give you $200 and you don't have to work, well, I mean, That's just your starting salary. It doesn't matter how many hours you're going to work, but you're going to get that $200. And then we're going to pay you a certain amount per hour after that. So, and what would that amount per hour be? Well, this is going up by $120 every 8 hours. So the crock on this one is 120 over 8, and that equals 15. So that means that they're making $15 per hour. However, they're giving you $200 to start off with. Now for the second graph, that's 0, 0, 8 and 200, 16 and 400, 24 and 600, 32 and 800, and then 40 and 1,000. That's going to be probably about right there. Okay, so this is going to be a straight line as well. Put it right about there. Okay, so there's the graph of both sets of data. This is number 2 and job offer number 2. So the question really would be in this case, which job should you take? So it looks like the solution is right about here, right about there it looks like. I'm sure if my graph was perfect, it would be right there. And that looks like it's at 20, the point 20 and 500 is what it looks like. So the solution to the system is the point 20 and 500. And in this case, what does that solution mean? Well, it means that for 20 hours of work, so for 20 hours of work, both jobs will pay $500. And then the question is, well, which job offer should you take? Well, if you're going to work, you can see that from 20 hours on to 40 hours a week, job offer 2 makes you more money. But if you're going to work from 0 to 20 hours, job offer 1 makes you more money. So depending on how many hours of work you're going to work in a week, one job is better than the other. So for less than 20 hours, job offer 1 is better, pays more. And then for more than 20 hours, job offer 2 pays more. But at 20 hours, right on the nose, neither job offer is better. If you're only going to work a 20-hour week, you could take either job and make the same amount of money. Okay, that's it for this video.